Let me welcome you this morning. My name is Alan Schmuck. I'm the Vice President of Business Development with BioNova Natural Pools. I've come into this industry in an honest way. I mean, at the age of 12, I was throwing calcium hypochlorite into my first pool and coughing and hacking, and got to know how to spin a vertical grid DE filter, started in pool maintenance. This is all at the age of 12. And that set my career path. Actually, my path was more Jacques Cousteau related because I had an interest in marine biology and oceanography. I studied that in school. But when I got out of school, I realized he had the job I wanted. So I went back into the pool industry, and I worked retail, construction, sales, service, commercial, residential, final liner pools, fiberglass pools, concrete pool, everything. My landing spot for 30 years, though, was in the chemical industry. Spent 30 years with BioLab, and most of that time teaching dealers, service peoples, clients, homeowners, pool owners, how to maintain chemical pools. Because it's important for chemistry, that the chemistry be right, that the chemistry can work. Now, the science behind that is interesting, and because I was knee-deep in it, I became very attuned to the chemical side, and I love the science. James Robin and his company, Ren Robin Pools, was a client of BioLabs for many years, and I got to know James and his wife, Hey Son, on the tennis court, actually. And as we struck up this friendship, in the years that went by, James came back from Europe with BioNova Natural Pools. He was displaying at the International Pool and Spa Expo, and it just really piqued my interest. Hey, Bob. I was pretty well situated with BioLab. I had a 401k and benefits, and didn't want to go into BioNova at the time. But 6 years ago, I had the opportunity. James called me up in my seeming retirement and said, "You're not really retiring, are you?" And he said, "Come on with BioNova. It's really taken off. We need some help." So that's how I got started. It's been a real passionate side of my career and interest in the pool industry. It's connected me with a lot of interesting people. In fact, we have, I'll say, a notorious, infamous Anthony Archer Wills of the Pool Master on Animal Planet. You'll see if you go YouTube, Google search his series. I think there's 6 or 7 series that he has on YouTube. He has assisted us in many, many projects. In fact, you'll see some of his work in the slides I'll present today. However, I will mention that any of you in the area, Anthony lives in upstate New York, if you ever have an upstate client that is wanting to really imagine and get a good sense of wonder that can be created, Anthony has such an imaginative and creative mind and a passion for sustainable, nature-based solution. He's a great partner in these kind of endeavors, and we welcome he and his wonderful wife, Pauline. Yeah, his better half, obviously. I also want to recognize our project manager, Ryan Harmer, is here. Most of the projects you see that we'll be presenting today, Ryan has been on site managing. I mean, I got the easy side. All I got to do is explain it. He's got to build it. So, but with that, I want to welcome you to the basic course on natural swimming pools. But let's talk about what we're going to be going through today. Today is basic NSP stuff, the biology, the science, how it works. And for those of you who had an aversion to high school biology, put on your thinking caps. This is not new stuff. It's science, and the biology of limnology covers a lot of things, and what we try to harness, what we harness in building natural pools is optimizing the conditions that allow the biology to occur. In today's afternoon session, we're going to go over more of the design and construction considerations for natural pools. But the real issue happens to be, what are you doing about it? Do you have clients coming into your store, or are you in their backyard servicing their pool, and they're asking you, "Hey, can I do a chemical-free pool?" Your objective today ought to be to have enough information to go back to that client and that inquiry to give them a good, educated response. But by telling them, "Oh yeah, we got a salt pool," yeah, okay, salt pool, as you all know, it's a chlorine pool. But it has been that little gap of offering to clients because you're familiar with salt pools. You're familiar with the chemistry of salt pools. But the whole familiarity with natural pools leaves many of you wondering, oh, this is snake oil. This can't possibly work. I've spent all my life in the pool industry, and it's always been about saturation index and pH and total amount of free chlorine. Yeah, there's none of that in a natural pool. Nature takes care of these things in a very orchestrated and absolutely symphonic kind of way, the way everyone contributes, all the many, many myriads of molecules and plants and life forms that contribute to this. There is a growing interest. I mean, if you haven't noticed, the conscious sense of environmental sustainability topics is high on everybody's mind. You can't go through a news cycle today without hearing the latest version of whatever climate change is providing, or the latest storm surge, or a sea level rise. That's just climate change. But there's also upcycling, recycling, circular economy. Electric cars are everywhere. People are focused on environmentally sustaining our existence, and we need to have options for them to consider. Many people are coming in your stores, well, let me rephrase that. Many of the people that are considering a natural swimming pool are not even considering a chemical pool. Let me restate that. Many of the people that are considering a natural swimming pool are not even considering a chemically treated pool. Now that's important for you to know because natural pools are not competition for chemical pools. These are different clients. The good news is they're usually very well off. They have a very interesting design, something that's outside of the cookie cutter installation manner. So they're fun to build. But the fact is, if you can get that client into your store and they understand you know about natural pools, you'll have another genre, another niche of swimming pool opportunity that you can provide. And it's not going to upset your chemical-focused retail. I mentioned to some that, well, yeah, you don't need chemicals. And somebody said, well, how am I going to make my money? I'm not going to sell them chlorine and shock. Well, no, I mean, profit on a client is a big bucket, right? So you can gather that profit either up front, long term. Fact is, if you gather them long term and you address their needs for natural pools, they're going to have friends. Don't people, birds of a feather flock together? People of similar interests flock together. So you got to believe that this client that's interested in a natural pool also has friends that would be interested in that. So when you get into that niche, you're going to find a whole new arena to participate in. We're going to talk about how natural swimming pools work. Later today is the design options. And there is an emerging use of biofilm filters that we're going to cover also. Because I bet in your mind, if you picture natural pools in your mind, you're thinking a pond. You're seeing lilies and lotuses and cattails. Well, that is a type of natural pool. We refer to those as bio-swim ponds. But a natural swimming pool can look just like a regular pool. How the pool is constructed and how it looks has nothing to do with it being natural. We've got rectilinear, classic shape design natural pools with a biological filter hidden out of sight. And to the uneducated observer, you wouldn't even know that it's a natural pool. No plants, just clean, soothing water. Now, if they want the plants, there's certainly a way for that. But realize how it looks has nothing to do with it being a natural pool. Now, it's the things that are driving our growth. And I will say that from 2020 to date, interest and contacts and leads from our website have doubled year over year. With that, you got to think, there's something going on here. And if you're not involved in it, if you're not understanding what they're asking for, then please make sure you understand or have an understanding so you can give them a good response. If nothing else, say, I don't know, but I do know BioNova, and you can get us on the phone. We'll do a Zoom call, have a client meeting, answer the questions, and go over a lot of things. But as we go through all the motivations for why people are considering natural pools, they're not going away. Do you suddenly think that environmental sustainability topics are going to disappear tomorrow? No, it's just not going to happen. So this rising tide of interest is something that all of you can float your boat on. Now, what is a natural pool? It is not the pond in your grandfather's pasture, though that is a natural environment. A natural swimming pool is a constructed, engineered vessel designed for swimming with a separate area for the biological filter. That biological filter can be a big pond area or it can be a smaller biofilm filter area. It also is going to be totally chemical free, no devices. Some in our industry are embracing UV, and I'm not really against UV. I mean, after all, sun is a big UV agent. We're right in the middle of all of it. So UV maybe, but no ionizers, no silver, no copper, no ozone, no chlorine, no water balancing, no pH management, because in a natural pool, the pH of the water is basically going to take on the characteristics of the environment that you're in. Isn't that what happens in nature? If you go out to Smith Mountain Lake and take a sample of the water, you're going to get a different result for pH than what you get in the mountains and streams of North Tennessee, North Carolina. So in a natural pool, we just let it adapt to the temperatures of the climate. Now we do have a couple of different types of pools. We refer to those for semantics as bioswim ponds as the classification of a natural pool that incorporates a planted regeneration zone. That's the one you have in your mind. The lotuses, the lilies, the plants. Those systems usually require, those regeneration zones typically need to be approximately 50% of the given swimming area you've dedicated for the swimming area. So 600 square foot swimming area needs a 300 square foot regeneration zone. So my project is 900 square feet of waterproofing. It is isolated, and the area that is designed for swimming and bathing covers and is designed according to ANSI and ICC standards for depth, slopes, entrance, exit, suction entrapment, electrical grounding. None of that stuff is happening on a ornamental pond. Now, an ornamental pond and a natural swimming pool do have many things in common. The biology that's at play is the same. We're just making sure that the vessel you're designing is appropriately designed for the purpose in which it was intended, and that is swimming and or diving.
Al?
Yes?
Can I ask a question?
No. Yes.
So how do you address, you mentioned it with water chemistry. I mean, I've been taught that vinyl liners and fiberglass finishes and plaster all have to have certain pH, calcium hardness levels. And how do you address that?
Well, the reality is that the acceptable pH range for a natural pool can range from 5.6 to 9.2. We do have some recommendations on pool surface interiors that are both accommodating to that environment. We use a lot of PVC membranes. Eco-finish on concrete pools, acceptable. I don't think you'll find the characteristics of water quality in a natural pool detrimental to the cementatious interior of a gunite pool. Fiberglass pool and the composite pools, they're impervious. That's,
What?
they're their surface, the new composite pools, fiberglass pools, are not going to be affected or by the water quality in natural
So
pools.
the manufacturers of the liners and the fiberglass interior finish?
Yeah, well, they're concerned, most are concerned with the chemical characteristics of the entire package, not necessarily just the pH. So, but in a natural pool, it is not as much of a change, because it's not changing as much. I mean, you know, in a chemically treated pool, pH fluctuations can happen based on rain, bather load, chemical applications, all those things. You'll find that in a natural pool, it's a lot more stable, less likely to have the peaks and valleys and changes in it. Now, this is a natural pool, but you'll notice there's really not any plants in the environment. There's no regeneration. This is a natural looking pool. In fact, it's a biofilm filtered pool with the filters off the screen here. But y'all are in a great spot now. to benefit from this interest in natural pools. So back to my previous challenge to you. Leave here having an understanding to give these clients that come in asking, do you know anything about natural pools or chemical-free pools? Just say yes. I know enough to make me dangerous, but I know people who know, and we can get you on the right track. Our website, BioNovaNaturalPools.com, will give you a lot of information and such that you can download. Now, when I was in retail for many, many years, and I'm sure you'll testify to this too, is you got people coming in all the time saying, I'm allergic to chlorine, or it irritates my eyes, or they want to get away from chlorine for any number of reasons. I am not anti-chemical, first of all. And the purpose of this presentation is not to displace the chemical portion of our industry from your business. It is to gather new clients with different interests other than what's addressed by chemistry. So you hear it all. I'm allergic. Mostly what we're seeing is I just want a sustainable option. Help me understand what I can do. As we mentioned, it's not a salt pool. We don't use zinc, copper, silver, none of that, because those biocides, silver, copper, zinc, they will also affect the beneficial microbes we're trying to nurture and form in the system. The real obstacle has been the lack of local knowledge that people can call on to help them with this project. I've spent a lot of my time, almost like eHarmony, matching a client with an interest in the Midwest with a builder that I may or may not know that could build it, and linking them together so that that knowledgeable, educated builder can work with the client to understand what they want. Then we plug ourselves in and integrate a biological filter design into their construction plan for the pool. We have 20-something projects going on around the country right now with that type of scenario of project management. It's difficult without an interested professional in a marketplace. So you don't have to hang a shingle out and say, we are the natural pool specialist. You just have to have an understanding and a knowledge so you can direct their interest to the appropriate solution that you can have other than a chemical pool. Now, the history of NSPs. I'm sorry, I think this slide came up late at night because, what's the history of natural pools? Well, in the beginning, natural water and the methods and treatment for natural water environments has been around since the beginning of time. And all we've done is take the opportunity to optimize those conditions so that we can enhance the result. The very first natural pool, swimming pond, was built by Werner Gamrith back in 1983, so 40 years ago. This is a picture of it. It is a type 1 pool, according to NSP standards, meaning there is no mechanical, technical movement, circulation of the water. It is entirely built using limnology principles that include depth, size, surface area, and the passive circulation of the water is slow, and because the water movement is slow, plants can flourish as they absorb the nutrients. And it's not just the plants you see here, there's submerged plants and marginal plants. A lot of plants required for a system that's not mechanically and technically moving the water. So as NSPs, natural swimming pools and ponds, evolved, technology became employed, movement of water. We can manage the flow of water. In fact, in Europe we refer to the pond designs, like you're seeing here, slow flow filters, because it defines a flow rate necessary in order for those to succeed. In nature, ponds are very passive circulation environments. But water in nature doesn't only exist as a pond, it also has rivers and streams, faster moving water. You're not going to find plants there. And that's kind of the elements that define the biological biofilm filters that we'll be talking about as well. The very first public natural pool in Austria in 1990, 10,000 square feet. Munich, 1998, the first public NSP, 18,000 square feet. Point out, you can see the regeneration zone for this pool up in the upper right-hand side, and the big pond area. Folks, I'm not embarrassed and I'm not ashamed to say, don't expect Windex blue water. This is living water. You've got phytoplankton, zooplankton, diatoms, you've got all kinds of things living in the water, and those miniature microbes cause the water to have a hue or a tint. It's not unusual. You should expect clear water. According to the safety standards of the industry, you should be able to see 3 meters unobstructed on that visual disc. I'm sure you've all seen that your health department throws in the bottom of your pool to make sure water clarity is fine. We expect that in a natural pool. Now, the first public pool in the U.S. we were involved with back in 2016. Actually, the process began 4 years earlier. Now, if you're not aware, public pools require different standards for construction than a private pool does, right? There's Model Aquatic Health Code, there's the PHTA Alliance and the ICC, those standards related to the guidelines for a chemically treated public pool. So in order to get a natural public pool, it did in this situation require an act of Congress. They actually changed law in Minnesota to allow biological filtration in this pool. It is 22,000 square feet of surface area and over 16,000 square feet of regeneration zone. I've got a better slide of that a little bit later, showing some of the construction techniques that I'll show later this afternoon. But this pool is unique in the United States, and it's become a focal point, a real source of pride for the folks in Minneapolis. Well, now, we're not alone. BioNova is not the only entity. In fact, the International Organization of Natural Bathing Waters, yeah, give you a chance to giggle, because I did. First time I heard, International Organization of Natural Bathing Waters. There's really an organization like it. It is the international assembly of folks from all over the world. And for the past 5 years, we've traveled to Europe and in Vienna, Warsaw, Frankfurt, Brussels. That's where the action's happening related to advancements, understanding, and actually experience. The IOB, if you go in on the website, IOB, matter of fact, I think I'll link this. Yeah. Oh, I didn't set my internet up. Sorry. The IOB is the parent organization, and I'm sorry. And ultimately, their role is to ensure that as a governing body, they're providing the expectations and the criteria for what is a natural pool. And ultimately, the very first thing, one of the things that was developed about 2 years ago, is the common essentials. Now, these are the elements of a natural pool that are required, expected, in order to be considered a natural swimming pool. It's a nature-based solution. It contributes to a circular economy, so we're not using materials that are ultimately wasteful. We'd ideally like to use the most sustainable construction practices and materials possible. But we want to go through a planning process. We want to make sure the customer expectation understands that a natural pool is different than a chemical pool and what those differences are and how they should expect that pool to be maintained and behave. The internal configuration, as I said, is going to be identical to the ICC and ANSI standards that you currently construct pools related to, depth, slopes, and so forth. We don't want runoff water, surface water runoff coming into our pool. You don't want that in a chemical pool. But it's standard. We want it sealed against any. We don't like and we don't promote natural bottom pools. We want a sealed interior to isolate and allow us to circulate and filter only that water. We want to use native plants. Plants that are specifically for the purpose of, and bred and cultivated for the purpose to be in natural pools and be in your proper climate zone. We don't want them to be invasive species. We don't want you contributing to ecological disaster by planting the kudzu of your pond and having it distributed all through your neighborhood. So ultimately the water testing is something that there's very little that's done on a day-to-day basis, but prior to starting up and getting the system running, we want a water sample from the source water. And we want to test any gravel media we're using to ensure that there's no mineral components, primarily phosphate, that can maybe derail the startup process or encumber the startup process to make it a little more difficult. So these things all lead up to this final element about the indicator organisms. The indicator organisms in a chemical pool are E. coli, Enterococca, and Pseudomonas. Those three indicator organisms are the same indicator organisms that we use, the World Health Organization uses, CDC uses, and the IOB uses to monitor the water health. We know that if E. coli, Enterococca, or Pseudomonas exceed whatever the World Health Organization or CDC has said, we know that if we look at it and we see an exceptionally high amount based on the guidelines, I think I have it in the next slide. If we have Enterococca in the pool over 800 parts or CFUs, it's probably likely that other pathogenic organisms are also going to be thriving. These are the canary in the coal mine. Same as in a chemical pool, we maintain values at or below those that have been implemented through the World Health Organization and CDC. As you can see, pH value range from 6 to 9.5. Phosphates, we want about 10 parts per billion or less, especially in the fill water. If it's in the fresh fill, we may want to truck water in to give the best possibility for a good startup. If not, we can manage that. Visibility is still a consideration. We want to make sure that it's safe, that you can see the bottom at 4 meters in depth. Water temperatures is what it is. We do not want to artificially heat a natural pool in excess of 86 degrees. So ideal temperature for a natural pool is between 50 and 86 degrees. That's what nature says. Biological activity really begins to ramp up around 65 to 70 degrees. And as the water warms up, all these biological critters come online and begin doing their job of reducing the nutrient load in the water. These technical standards have to do with the construction method and how we end up moving the water. So let's talk for a second. How is this water purified? It's not killing anything. How is the water, we're not shocking it. So how are we keeping the water safe? Nature's role, nature's objective in all food webs is competition for resources. Those who have the resources live and thrive. Those who don't. Opportunistic species take advantage of these exceptionally high levels of nutrients. But what we're trying to do, we're trying to create an environment where all of these participants are all evolved in a cycle of consuming and production in order to make this a sustainable cycle of life. The producers are phytoplankton, heterotrophic organisms, things that can create food source. Photosynthesis creates a gas and a sugar, right? And it's that ultimately it's the results of their consumption that provides food source for the reducers, like fungi. It's also happening in our soil. This is not an isolated environment that only happens in water. This bacteriological workforce is a team of organisms all working together as a community. This is not just one thing. There's billions, not Carl Sagan, man, billions and billions of these organisms that are participating in this community of reduction, consumption, and clarity to remove the nutrients from the water. This community syntropy is defined by the ability of one organism's metabolic output to benefit another organism's metabolic uptake. So whatever I'm putting off, the other organism actually can take up as a food source. And that is perfectly illustrated in the nitrogen cycle. Because as we get an ammoniated organic matter, dirty water that comes in the pool, the very first thing that happens is that ammoniated compound needs to be broke down. Ammonia is not good for anything. And to illustrate how specialized these bacteria are, there is bacteria that is specifically focused on taking the ammonia and converting it to nitrite. Not only that, but there's another specific bacteria whose focus and role in life is to convert that nitrite to a nitrate. Now, why is that important? Nitrites can't be used by plants. In order to get to a usable form, a nitrate has to exist, so that Nitrobacter bacteria takes that nitrate, converts it to nitrate. Now it can be uptaken by phytoplankton in plants. So this circular use of resources in food sustains the entire cycle. And as long as we have a healthy environment, it will keep on going, sustaining that environment, and eliminate opportunistic organisms from coming in. Now, what's an opportunistic organism? Algae is the number one opportunistic organism. Always in the water. I think in lives gone past, you probably have been told that there's so many hundreds of thousands of spores of algae in a liter of water, a quart of water. Yeah, I mean, algae's everywhere. And it's just waiting to grow. But it won't until there's an excess amount of nutrients in the water that it can take up and begin to thrive. If we have a very healthy microenvironment, we're consuming the nutrients without any excess. And by not having that excess, there is no opportunistic growth that will happen. Now, fact is, it's biofilm that is the focus. Biofilm is what we want to foster the development of. Now, biofilm is that community under one house. Biofilm is an assortment of many, many types of organisms, all living under the shell of an encapsulating polymeric substance, the slime, the film of sorts that covers it. The film protects the community. The film sequesters nutrients. The film makes the colony, allows the colony to grow under its house. And when it reaches a point when it's reaching bursting capacity, it disperses downstream. Key point of this. Water flow rate is an important aspect of this type of distribution. Meaning, they don't swim, they don't walk, they don't fly. They're relying on current and water flow to disperse them in the environment. And in our system, same thing is happening. We're creating an environment where we can control the movement of the water to take the best possible advantage of the surface area in the biological filter that's been provided. And so long as the water is moving, the biofilm distributes, and life goes on. This entropic environment is an important aspect of any natural environment. The fact that the metabolic output of one organism is benefiting the metabolic needs of another makes this beautiful and orchestrated so that it just can go on and on with, as long as there's nutrients and water flow and the temperatures are right in temperature, these organisms will grow. They're ubiquitous to our environment. So what's it require? It requires a surface. These organisms don't want to just free float in the water. They want to grow on a surface. That surface could be the interior of your pool, steps, walls. We don't want that. Ideally, we'd like a nutrient-deprived swimming environment. Because a nutrient-deprived swimming environment means it's not going to support growth. But we want the growth going on in a biological filter, thus the flow rate importance. Now, in this case, we need a surface. We can provide that surface through gravel of different sizes. In fact, we can create hundreds of thousands of square feet of surface area using properly sized and proper type of gravel for the biofilm to grow on. And I'll show you examples of how those are designed and worked into the system. But it's that surface. It seems very simple, but that surface is what's required at a proper temperature, between 50 and 86. I don't know how many of y'all enjoy swimming in waters of 50. I'm like an 82-degree guy. The water flow rate is the thing that is going to define two different categories of pool. Remember the slow flow filters? Biofilm filters are fast flow filters because we need that flow rate to disperse the biofilm downstream. And then, of course, we need nutrients to feed its growth. We want enough nutrients, anticipate enough nutrients, so that our biological filter can thrive. The phosphate, being one of the more important elements, is can be reduced in a lot of ways, and it's one of the facets of pool construction and design and preparation that we pay particular attention to, because phosphates can be broken down. They can be bound in filters. You know that with all the phosphate removing products that are out there on the market. They're mechanically removed. We can also make sure that we can have them removed by plants. There are some plants that are specifically focused with the purpose of uptaking phosphates. The biofilm itself actually can sequester phosphates on the surface of its encapsulating polymeric substance, the slime layer of its membrane. So in this case, as long as we have water flow and we can reduce the amount of detritus, the organic matter, then we can ultimately create a very sustaining natural environment. Unfortunately, there's many in the industry, or many think that, well, this is what a natural pool is going to look like if it's natural. No, that's not natural. That's not even natural in nature. That's over-nutrient, too many nutrients in the water. Typically the result, surface water runoff, agricultural fertilizer, lots of ways excess of nutrients can get into ponds, but it's not a surprise that many ponds that exist in nature are at the bottom of hills, and as rain washes those nutrients off the water, it's not unusual for that to happen. But we want a oligotrophic environment where nutrients are minimized. We're starving the pool. And by doing that, we're feeding the microbes and the biology that's in our filter. The clear water is simply the result of it being low in nutrients. If you get a 4-inch rainfall, there's going to be more nutrients than was in there before it rained. You may get a bloom of algae. That wouldn't be unusual. It's not unusual in a chemical pool. But what's unique about a natural pool, as soon as those excess nutrients are consumed, the system self-maintains. If there's no more nutrients, things die, right? I mean, that's what happens in nature. No food, no organisms. There's a lot of, I don't know how many of y'all ever remember looking at a drop of lake water underneath a microscope, in their first, high school biology, grammar school. There is a myriad of organisms, and the guy here in the middle, the Daphnia, he is an unsung hero of zooplankton, just a powerhouse as it relates to their involvement in the whole water biology, the biological process of the water. Don't be afraid of these guys. But in this case, anybody that's a bacteriophobe, they're probably not a candidate for a natural pool. They want a sterile environment. I get that. There's people out there that just, OCD about, maintaining the pool. Those are not clients for a natural pool. May not be. Make sure they understand we've got a myriad of organisms that are going to be growing in the water. Most of the clients that are coming to you with this request, though, for a natural pool, they understand that. And I only mention that and point that out because in a chemical pool, we're killing all these guys. It's indiscriminate. Oxidation doesn't care whether they're supposed to be good for the environment. Oxidation just oxidizes, indiscriminate. It's chemotherapy for the pool. The good, the bad, the indifferent, all oxidized and poisoned. In a natural environment, we're allowing them to thrive and provide the output, which is ultimately a nice, stable, natural environment. A couple things about Daphnia, that last bullet. There's 35,000 Daphnia in a cubic meter of water, 264 gallons. Each animal filters up to 4.5 milliliters per day. And that doesn't seem like a lot, but these are little tiny little guys. Lots of water filtered through them. And I mean, when you look at It's 16% of the total volume per day that's going through these Daphnia. And ultimately, it's also, the paper is written, that these Daphnia can graze on potentially detrimental organisms in the environment. Which is kind of nice. I mean, that's the whole food web at work. Folks are going to ask you, well, are snakes going to come to the pool? Well, are snakes coming to your pool now? If you create a regeneration zone with plants, granted, it's just creating a welcome sign for nature. In fact, as you add plants in a regeneration zone for a bio-swim pond, you're actually extending the type of food web you're creating. You've got plants, and with plants you've got insects. With insects, you've got insect larvae. With insect larvae, you got reptiles and amphibians coming to feed on them. And with those reptiles and amphibians, you've got other predators, raccoons, possums, herons, osprey, hawks. You're creating your own little backyard, wild kingdom that you can videotape. It's beautiful. I love this stuff. I mention that because some people don't want that. They may want to have a natural pool, but don't want to invite a lot of creatures, so a biofilm system that looks like a regular pool. You add plants, you welcome a lot of nature. So let's talk about bioswim ponds.
Alan, may I say? The amazing thing about these systems is all those critters you were showing, the frogs and the amphibians and the dragfish, equal no mosquitoes.
Oh, right.
We have never had a mosquito by our swimming pond.
Sold.
Yeah. Yeah, thanks, Anthony, because that is one of the most popular questions. Oh, well, what about mosquitoes? Not only is nature doing its own to police and prevent that, but also this is not stagnant water. And mosquitoes don't want to breed. They won't breed in moving water. I mean, they may be despised critters, but they're smart enough to know their offspring are not going to survive if they drop them into moving water. And our water is always moving. But we want to use native species, always. We want to create a diverse planted environment so that we're not reliant on one specific species of plant. And we want to make sure that the density of plants is appropriate for the size area we're trying to maintain. Well, in this case, we're going to use three different classifications, three different types of plants. There's the marginal and emergent plants, those that grow around the margin and edges and the very shallow water of a typical pond. They're usually high-growing, colorful. I mean, I tell some folks that picking out plants for your regeneration zone is kind of like picking wallpaper. There's so many colors and textures and such. You just have to go through, look at your climate zone, see what really trips your switch, and we can pick and choose what's best for that environment. They typically, these are very good at adding oxygen through the water. They're very good at their nutrient uptake through the roots. But realize, even in a planted environment, the nutrient load is reduced 80% by the biofilm, the microbial action that's going on in the planted substrate, around the roots and rhizomes, in the material that the plants are planted in, not by the plants themselves. About 20% reduction by the plants, which demonstrates and shows you that we can do a biological filter without plants. Plants exist in this environment because they can. The water's slow enough, doesn't wash them away. They're seeded by nature, land, grow because they can. In a biofilm system, the water's moving too fast. In a river, water moves too fast for plants to anchor down. But if you've ever tried to walk across a rocky creek and slipped on the rock, you slipped on the biofilm growing on the rock. Nature knows how to take care of its own. The submerged plants, these are underwater. Any of you have aquariums, you're probably fascinated watching some of these submerged plants actually percolate oxygen bubbles off of it as they create oxygen. They're great for nutrient uptake on all the plants, but usually oxygenation is one of the great things that this this criteria, this type of plants provide. Then there's the floating plants. These are the sexy ones, the one you see, you know, the lotuses, the lilies. They require deeper water, but they grow and float typically right on the surface. Now there's a great purpose for them in our environment because they provide shading and cooling of the water. Know now that most regeneration zones are shallow water. The deepest areas that we need in a regeneration zone really is only about 3 feet, maybe a little bit deeper. Well, that shallow water in the summer can get hot quicker. You know that, right? Well, these plants provide that shade cover. Not only are they providing shade cover, they're providing structural cover for larvae and zooplankton and all to feed. You know, like the mangrove swamps around our coastline that protect and harbor in the nurseries of our seas. These environments harbor the nursery and development of the zooplankton and such that are feeding underneath the surface. These are kind of tricky in some cases. Sometimes people are drawn to species that may not live or thrive year after year. You know, plant them in the spring, they look beautiful, but maybe they're from outside the climate zone and they don't thrive. We've got clients that'll reorder lilies or lotuses year after year because they just get infatuated, like many people on plants get infatuated with plants. And that's the nice thing about this regeneration zone. If you're planning a regeneration zone, you've got an aquatic garden. And for all the good or bad about that, if you love gardening, you're going to love this environment because it's a whole nother genre of plants. But realize that a garden's not going to take care of itself. So maintenance, using or having a regeneration zone does require some maintenance, but you're not out there mowing it every day. Usually it just requires in the end of the season cutting the plants back to remove that detritus so that it doesn't create organic matter to sit there throughout the winter. And then come spring, nature knows what to do. It just bursts to life. Temperatures, sunlight, everything comes in line. The rhythm of the seasons take over, and these plants thrive. Did I see a hand go up for a question? Now, in our environment, we have basically the construction method as we start to go through the different types and styles of NSPs. It's really around what are we excavating? Because I can excavate one hole and it's less money. I can put both my biological filter and swimming area in that one excavation. Or I can have the swimming pool located here, maybe at a different location or a different level, higher or lower. I can take the regeneration zone and install it separately. Well, the downside of that, of course, is now I've got 2 swimming pools I'm installing.
Can you make a trough regeneration zone?
Yes. Matter of fact, I've got a project we're doing now. When you say trough, it's actually the perimeter around an 81-foot rectangle,
Nice.
5 feet around the entire perimeter, wrapping around the pool. Yeah, it's beautiful. Yeah. Yeah, like that. Yeah, like this. Yeah. Where I've got this regeneration zone. So you see the segregation wall where we separate the swimming area from the planted area, and you'll see lots of examples in how that's done. There is no one way to do this. In fact, I don't think any 2 of our pools have ever been the same. They all have their unique personalities. But so we've got several different options. The bioswim pond that we talked about is with the regeneration zone. 50% of the swimming area dedicated to the regeneration zone. The biopool, biological filter, no plants. Much smaller biological filter area. And notice, I don't call it a regeneration zone. It's a biofilm reactor. It's creating biofilm. Affectionately called a box of rocks. In that same 600 square foot pool, I need a 4 by 12 or 48 square foot surface area to house the biological filter. So immediately you think, oh wow, 48 square feet versus 300. Yes, the biofilm biopools are less expensive to construct because I'm not having the larger regeneration area.
What's the drawback?
It doesn't have plants. For somebody who's wanting to have plants, that aesthetic of looking, then yeah, that's surely the only drawback. All of our projects right now, except the one I just mentioned about is our biofilm systems. Now, I also see there's many hybrids that we're creating. Because when I go through the exercises, saying, okay, well, your 600 square foot pool, if we put a regeneration zone, it's 900 square feet, and then it's $225,000. Or I can get a 600 square foot pool with a biofilm system, approximately 50 square feet, and it's about $130,000. Oh, well, you know, I really didn't like plants that much anyway. Many think that in order to have a natural pool, they got to have plants. That's the first thing that's just built. You don't need plants. I like plants. And if you want to make the best use of both, we can do a hybrid, where we design and create the biological filtration with a biofilm system, and then add an ornamental pond environment to the system. And we can plumb it so that it's moving water, but we're not going to be reliant on the plants for biological filtration. We're not relying on it. That's just going to give them the kicks and giggles. It's going to check the box of, oh yeah, I wanted a planted environment. Oh, I want lotuses or lilies. So they can have their plants and eat it too. That works. How are we doing on time? Well, that actually, were y'all all going to be here for the 1 o'clock session?
1:30.
1:30 session?
What's that?
It is on pool design. This is where, because if you were, I'm just going to go ahead and start in here with pool design. Yes.
I just have a question before you.
Okay.
What happens if you need to shock a pool? What if there's something that happens that contaminates your pool? What do you do?
Yeah, there's no need to shock it. If the problem occurs, it's occurred because of an input, right?
Yeah.
Something happened.
Yeah.
Identify what the input is and stop it. First thing, if your bathtub's overflowing, the first thing you do is you turn the faucet off. So in this scenario, find out where that nutrient input is coming from and stop it. It can be filtered. In fact, we use filter enhancing aids to aid in the reduction of phosphates and other products in the water. It is that's a mechanical removal. There's no chemical activity going. It's just the agglomeration of this phosphate molecule being tied up or bonded with the lanthanum or alum that's in the solution. But that's how we reduce it, and then the nature will take its course.
Okay, I guess particularly with public swimming pools, I know typically regulations require you to be able to shock it in case people matter for it.
Yeah, well, I can go. I've got a whole day-long seminar on public pool considerations. Right now in the U.S., natural swimming pools and biological filtration requires an exception or a variance from the public health department in order to be put into that. And we would identify and address any of those concerns relative to that design at that time for those folks. So, but there is a way, and the beautiful, the elegance of the system is, if you stop a nutrient input that is supporting a bloom, the system is self-limiting. They consume the nutrients, and then once that's done, party's over, and the system self-corrects. So if we have a proper design where we're eliminating excessive nutrient load inputs from surface water runoff or wherever, then we can maintain pretty much a problem-free pool. And if the exception happens where it suddenly turns, figure out what caused it to turn. And usually it's a filterable option.
One example, I'll give it.
Yeah, go ahead.
So I maintain a natural pool 3 days a week during the swimming season. One day showed up completely green, or completely clear the other day. Now it's completely green. So the question is, what happened? So I was able to kind of look into the shallow end and saw huge clumps of dirt in the pool because the gardeners had come and weeded all around the pools, and they put it in a big tarp, and then they sling it over their shoulder. So sure enough, they had slung it over, and at least it was 2 or 3 just clumps of dirt. The amount of nutrient and phosphate, that's just straight up fertilizer. So there it was, netted it out, vacuumed it out, and when I came back 2 days later, the pool was crystal clear. What with shocking, the biggest problem to note about shocking is you will kill everything in the pool, including all of the things that are filtering the pool.
Right.
So if you do that, it's going to clear the pool, then the pool's going to turn completely green again, because you have nothing filtering in it. So I wanted to point that out.
Thank you.
Thank you, Ralph.
So from a design standpoint, you're working with the client, and one of the first things that need to be identified is, like you do in your normal everyday life, trying to put a client with a pool, what do they want to use it for? How many people are using the pool? Number, types of bathers, area. Are they a doggy daycare center? Well, that's fine. Biological filters can certainly handle it, but we need to know what the biological load's going to be so we can anticipate and understand what the consuming side, what the biological filter needs to look like. So from that aspect, we can end up creating a design based on their own aspects of enjoyment and what they want to look at. Because usually I'll ask folks, well, what's motivating you to get a natural pool? Is it because you heard about it, or you saw Anthony Archer Wills on the Pool Master, and you say, yeah, that's why I always wanted one? Or is it simply a matter of an aesthetic appeal? We get a lot of landscape architects and designers that will come in with their beautiful little rendering designs, and you know, you gotta love designers, and maybe landscape designers in the room. And you know, what ends up showing up on that first rendering may not ultimately be what shows up on the final end result. The most important input is going to be what the client wants to look at. So I ask them, what do you want to look at? When you close your eyes and picture your background, tell me what you see. And if they go off with, oh, this planted garden space, then they're really plant focused. If their focus is on, yeah, I just don't want to swim in chemicals, or I just want to have a more sustainable, or we're growing our own garden and doing our own recycling, and we're trying to do things that are more responsible to the earth, and then walk them through the process. Ultimately, we don't end up determining what the construction method is until we understand what we're trying to engineer. In many cases, well, for instance, a gunite or shotcrete pool may be an over-engineered solution for a pool that could be assembled either using a one-piece fiberglass or panel steel wall PVC membrane. So once we understand what we're going to be designing, then we'll usually determine what the construction method is going to be. The interior waterproofing, Bob, this kind of goes back to your question you had a little bit earlier. We suggest that it should be non-porous. Now, what's non-porous? So you think all of them are non-porous because they're holding water. Well, the fact is, the cementatious surfaces that are used in the industry may have enough porosity that these organisms that I told you want to find a surface to grow on will find that porous nature of the surface easy to grow into and just makes it more difficult to clean. It does not undo the biological filtration. Actually, some would argue in our industry of cohorts that, oh well, if it's creating a biofilm inside the pool, that's even more biological filter. And that is true. But the client may not want to look at that. So in order to brush it off, a non-porous surface makes it a lot easier. We use PVC pool hide, 60 mil PVC membrane more often than any other surface. Very non-porous, long-lasting, customizable to interior configurations of the pool. And it's available in the muted colors that most people want for a natural pool environment. Not the bright topaz or bluish colors. They want muted colors to help enhance the natural design. Once we figure out how we're going to be constructing the pool, what the design and shape it is, then we'll look at the footprint of the pool and the necessary needs of the biological filter. We start with a plot plan, and we end up designing out like you currently do. You take your site survey, and then say, okay, well, what's your idea? In this case, the initial concept, what did you see? Well, I just want a rectangle pool in the corner. Well, it looked like it is a pretty small pool, but this is 91 feet long. The interior pool is 81 feet, So it's got a Junior Olympic swim lane on one side, but you can see around the perimeter, this is a bio-swim pond. It has 8 distribution shafts. You can see those by the little dots that are going around. Those distribution shafts, I'll have a better picture of them later, but you can see, is the common juncture point where a perforated pipe, under drain, that you see by these dotted lines, it's running underneath the gravel. So the water, in this case, is designed to be pulled from that, and when water is pulled from the distribution shaft back to the pump, it's creating a gravity feed system where the surface water is going over this segregation wall into the regeneration zone, into the distribution pipes, back to the pump, and returned through the pool returns. So the cycle is complete. In this particular case, we've got different depth areas. The shallow area, this closer area to the deck is going to be the deeper area for their lilies and lotuses, since they grow close to the water level. Marginal grasses along this back wall to provide some vertical height in the distance. But again, it's fun to work with your client, to look at the space they have and what they want to create. And I use the rendering options to show them, well, this is what it could look like. And this is that wraparound regeneration zone. And there's any number of ways this could be done. This is what works for this client. Now, the single vessel NSP design is probably, some of these are from our European cohorts and some are our own design, but I want to point out a couple of things in this particular installation. This is actually a steel wall pool, Fox pool design. The perimeter of the excavation is out here. So when this was excavated, we anticipated the need for the segregation wall. So before as we're excavating, putting the bottom in, we'll put a foundation to be able to stack and support. These can be anything. These can be natural rock. These can be landscaping. But this can be anything, just to segregate. It can be poured concrete masonry unit. We just need to isolate and separate the regeneration zone from the swimming area. With that, then all of this area becomes filter bed, pulling water, either pulling water down. We can also push water up using an upflow system as well. So based on however it wants to be designed, you can see it's a very interesting little entry area where folks are walking on path, these floating stones to the steps to walk in to their natural pool. All this area here is regeneration zone that's slowly pulling water through and cycling it through both the plants, the rhizomes, and the biofilm that's growing in the substrate that the plants are planted in. The single vessel design kind of illustrates the aspect of design that I was describing here. Segregation wall, the trough, in what's not shown specifically in this is the under drain, the plumbing, the perforated pipe that's underneath this, that's either pulling water down or pushing water out. In this case, I've got a gutter that's pulling water directly off the top of the pool, and as it does, it goes through a fine filter, the pump pulling through all this process, then returns it back. I can take this return water and I can direct it through normal return inlets into the pool, or I can direct it to be an under drain upflow where the water is returning, and ultimately in that case, it would get filtered twice. Once as it goes out of the pool and once when it comes back into the pool. Myriad of ways to design these, and a lot of it has to do with the orientation of the pool on the lot, what the prevailing winds are, right? You got surface circulation just based on where you locate the pool and proximity to trees and the wind direction. So all those things are important because we want to use nature to enhance and use the natural flow of the water that's taking that surface water into the biological filter first. We rarely, if ever, put bottom drains in our pools. Why didn't it affect circulation? Well, not really. Bottom drains may be more important in a chemical pool because of the importance of distributing the chemistry to that deeper water area. In our natural pool, all the nutrients that are going to be entering the pool got to go through the surface. bathers, animals, rain, wind, dust, snow, it's hitting the surface. So my focus, and our focus on designing the filters, is ensuring we're pulling that surface water efficiently off the surface of the pool into the biological filter. And that's how we maintain a nutrient-deprived swimming area. Actively as possible, pull surface water off and circulate it, and we're giving the nutrients to the microbes and allowing cleaner water to return back. The variations on design can be numerous, from the materials of construction to deck areas and how you want to what the client wants to look at. In many cases, the pumps themselves can be housed underneath decks or submerged. You know, we use burial vaults, quite common, to take the pumps out of off the equipment pad and into the ground. In this case, I believe some of the equipment is actually underneath the decks that you see here to the left. I put this slide in here because I want to point out, clients often ask, can we do a beach entry? Well, you can do a walk-in entry, that's cool, it's fine. I don't like having gravel in the pool or sand in the pool without having a way to circulate and move that water. It's a problematic area in nature, because as you get down into the silt, substrate, bottom material of most natural ponds, ultimately as it layers up, that area becomes anaerobic. And as it becomes anaerobic, the conditions and the quality, the vitality of that ecosystem changes. And it actually can provide a more suitable environment for detrimental organisms, pathogenic organisms that love to reside in that anaerobic environment. Plus the fact that it's just a catch for dust, and as you trot over it, you can cloud the water up. In this case, this is pea gravel, and the pea gravel stops right here. You see the wall. Underneath this pea gravel is an underdrain that's got 3/4 inch limestone that with a distribution perforated 4-inch pipe underneath that's pulling water. So water is not stagnant here. But I gotta tell you, I'm not a big fan of this purely because the rocks and pebbles is going to get kicked in the pool. It's just going to be a maintenance issue. As long as they understand that, that's fine. Key here is, if you're going to use a gravel, sand, beach entry, we still need to move the water through some type of measured circulation and distribution environment. The last couple of years have seen a marked increase in the number of folks wanting classic designs. You know, rectilinear pools, the easiest, most efficient way to enclose and build just about anything. The more linear feet of wall you put it, using freeform, the more costly it is. But there's something nice about the classic design of a rectilinear shape with nature. That's a taste thing. You know, I run into it a lot with folks that say, well, this is what I want to try. Can we do that? And usually we can work out a way. More of a formal garden type. The pool on the left is actually a converted pool. Was at one time a chemical pool. It needed to be resurfaced. This wall was constructed to isolate and identify the regeneration zone. It cut the pool down from about 800 square feet to about 400 square feet in the middle, and the regeneration zone on the side. We're doing conversions all the time. In fact, one of the easier ways to convert a pool is to convert it using a biofilm filter. We can just add it as a separate installed area around the pool, route the water through it. The pool on the bottom right is probably about the smallest size you'd want to consider for a bioswim pond. 700 square feet seems to be about the right match of regeneration area to swim area. You get much smaller than that, and it's really tough to get the depths right. We would encourage, and this is about 700 square feet of pool area and about 400 square feet of regeneration zone around. You'll see that their deep water area is here in this corner. And again, they've got their equipment pumps underneath the deck. Lots of ways to manage and maneuver these situations in your backyard. Now, the pool at Weber Park was a dual vessel design, meaning we had a separate excavation, 16,000 square feet of regeneration zone that was put out, and then 22,000 square feet of pool area. The water is all being pulled off the pool by gutter drains or surface collectors, so it's pulled, the surface water is pulled off the pool. As it does, it goes several routes to get to our regeneration zone. We've got a fine filter here where we can ultimately route some of that water, and then in this case, this is called short cycling the water, where it actually takes 2 paths through the filter before it ends up back to the pool. The fact is, and the simplicity of this is all simply about moving water through a much larger filter than you're normally used to pumping. The technical shaft at the end is we can have like a cistern where we're gathering surface gutter water into a larger cistern that's then connected to a pump, where my pump is using that cistern as a reservoir, and as it empties, it's being filled from the gravity overflow of the gutter drains. Pools on different levels are always, on multiple levels, is a challenging thing. If for no other reason than making sure that you get it plumbed right and you don't dump the upper vessel into the bottom vessel. In this case, in Mendham, the regeneration zone is low. You can see the top of one of the distribution shafts here and over here. But it actually is pulling water. You'll see another with a surface drain is just filter feeding or gravity feeding the surface water from the upper pool down into the pond. It gives you an idea of the water clarity. Robotic cleaners. Ideal. We use the Maytronics Dolphin, recommend them quite often, just to be able to brush and vacuum. And ideally, if you had one that could brush and then discharge on a pressure side to go to another auxiliary filter, that would be ideal. But water quality you should expect to be just, as Anthony says, gin clear. These pools, as you're saying, are this is eco green, isn't it? Yeah. This client loves this color, and we've installed this the same color that we have in Weber Park. There are colors and tones of PVC membrane that are more muted: olive colors, slate grays, French grays, things. If you get a grayish coloration or a black pigment into any of the coloration, the light that's reflected from the surface changes what you end up seeing here, right? Because this color is just a result of light bouncing off and coming back through the water. More muted colors like French grays and darker colors give that reflection pool environment. This just gives a nice bright green, clean looking, but they love it. This is the pool at Princeton that Ryan helps maintain. This is actually the client that first started us down our path to natural pools. Encouraged that they were interested in natural pools over 15, 16 years ago. And the original pool here was built all by itself. That's all that existed first. I said, we want a natural pool. So this is what was added. And this particular pond, I mean, it's much larger than it needs to be because the client just wanted a large pond area. You can see there's walkways and lots of grassy areas. It's almost an interpretive garden area for nature lovers. But this pool is now fed by a stream, and Anthony Archer-Wills did all of the stone and rock placement. I refer to Anthony when I'm talking to clients as our boulder whisperer. He can look at a boulder and see how it should be oriented, moved, and shaped in order to give the best position and effect in the environment. But natural elements are only going to enhance this overall design. Now the stream bed is how long? 100 yards, 200 yards? How long is that stream
The
bed?
stream, no, the one that goes in the pond?
Yeah, the one that gets from the driveway to the top of the pond.
Oh, well, yeah.
It may be 100 yards.
Yeah.
Anyway, it's good. Go to our website. We've got a nice little drone view of the overflight. It's a beautiful environment. And this is kind of a classic bioswim pond. All the elements of nature, the natural elements, the shape, the design, the feel. But there's nothing that says you have to have it looking like that. In Newtown, Connecticut, this client had a natural, well, this was an old swimming hole. It was fed by natural water spring, and you can see it is not very desirable. So the client came to us and said, we want to convert this. We want to manage this better. Well, the best way to approach it was to tear it all out. And they did. And in the process, designed in swimming area, regeneration area, rerouted springs around the perimeter of the pool, and then the end result was just a beautiful pool. It was probably the best view of it to give you a sense of the seating area, regeneration zone that goes around it, floating stones that you can walk over, and the deeper area. This was the inaugural event for the opening of this pool. That's the long dresses.
If I can go back to something you just said on the previous design,
Mhm.
you mentioned a stream. I'm assuming because you're moving water, that gives you the opportunity to create landscape elements like a stream into somebody's landscape as part of one of these systems. Is that correct?
That's correct. Yeah, and water features, whether they're a lengthy stream or just a source rock with water percolating and overflowing, water features in a natural pool just are as natural as peanut butter and jelly. They definitely should be considered as a part of the design.
If you have an existing customer that wants to switch over to a natural pool, can you use the existing pump and skimmers and plumbing, or do you need to do all this regeneration stuff? Can you just take the old filter out and put a new?
Actually, it'd be more additive than subtracting. If the pump and filter are in good shape and operating order, we'll integrate them into the design. In fact, we will generally design, even with our biological filter system, with biofilms, that we'll have a standard pump and filter to serve as kind of the central vacuum system for the pool. So if we're vacuuming, cleaning normal dirt and debris out the way you normally do in cleaning the pool, it'd be best to try to control and contain that in this separate filter than allowing it to build up in a biological filter. That only shortens its cycle time. So yes, we will typically, from a maintenance standpoint, include a standard pump and filter. So we would look for ways to use it if it was still usable.
But you know, what I'm saying is like, without having to do like a major renovation of the whole entire backyard. You just take
Well,
the existing pool and you just take the chlorinator off and put something else on.
Yeah, I mean, the process, the simple process would be adding a biofilm filter.
Okay.
So in that process, I would need a source to feed water to that biofilm filter. Generally, if we take, say, a biofilm filter vault and place it, I don't know, let's just say 10 feet away from the pool, I've got a 4 by 12 vault that goes about 5.5 feet deep in the ground. I excavate that vault, line the interior, and I connect it. We use skimmers with a 6-inch sump, like an Aquastar skimmer, and run it over. And that 6-inch volume is generally plenty to be able to feed the water requirements and flow requirements for most pools. Well, we use 2 skimmers. There's many skimmers that we got one up in Vermont that they just built a trough off of their pool to feed the water. So that's the most direct and easiest way. Adding a regeneration zone to an existing pool, Yeah, that's gonna be a little more complicated. It's not impossible, you know? Give me enough money and time and we can do just about anything. But those are the aspects of the design and construction we'll go over with each client to ensure that they understand what their options are.
Lighting, does that affect anything with the pool? No?
The brightness,
That's what I'm saying, with setting all this up.
I'm sorry. Yeah.
But nothing is gonna affect the
No.
filtration, what's going on with the natural chemistry, having lighting inside the vessel.
no, doesn't affect it. Heaters is the only restriction. We don't want to artificially heat hotter than 86 degrees. And the biggest reason for that is, and the follow-up that would be, therefore, we do not do biological filtration in hot tubs. So anytime you get the water temperature in excess of 86, you know, the whole concentration of gases in solution changes as the water heats up, minimizing oxygen and carbon dioxide, and it makes the conditions more suitable for less desirable organisms. Yes, sir.
You mentioned like artificial heating at above 86, but I mean, how often are you dealing with the fact that, I mean, I regularly deal with pools that are not artificially heated that are above 86 degrees.
Yeah, well, that's why I said, we don't, if it's a heating naturally, based on location, I'm not so concerned. What you don't want to do is artificially heat the water above what it would normally attain. So, I mean, if you got a big pool in the middle of, sunny area and it heats up that hot, then
Arizona.
yeah. Not a problem. We just don't want to artificially heat it more than that.
You're okay in New York heating into 86 in like April? When the outside temperature is,
Well, knock yourself out, you know.
50?
Gas company, electric company's gonna love you, but,
but don't use a artificial heater, or is it okay to heat it artificially?
oh yeah, you can use heat pump, solar, gas, LP, any means, just don't heat it in excess of 86 degrees.
This Princeton pool, as soon as we open it, April 1, temperatures are in the 40s, we heat it straight to 83. You're gonna lose a lot of water. I show up in the morning and it's a nice foggy scene, but it doesn't do anything to a water quality.
Anthony?
A couple of observations they mentioned over there. One is, of course, he mentioned a stream. A stream is like a huge biofilter in its own right because of all the biofilm that is forming on the gravel all the way along it. It's also adding oxygen and generally improving the water quality. So can be a plus. And the other thing that was brought up was about the skimmers. You can very easily have a vanishing edge or infinity edge with waterfall and all the pollen. Especially if you put it on the downwind side, all the pollen and leaves will be skimmed over, go into the biofiltration regeneration system, and all the plants will say, goody, here comes our food.
Food time, right.
So
It's a buffet, right.
That's another point. The other main point was that the temperature is much more constant in a biopool with its regeneration system, because there's so much out of the sunlight.
Mm-hmm.
All the water in that gravel is in the shade and keeping cool. So it doesn't get quite so hot nor so cold. It keeps it at a more constant temperature. That's what I've found.
Yeah, and the depth of the water, how deep you dig the vessel, the swimming area, getting down to that 6-foot level in the ground for the swimming area helps tap into that more moderate ground temperatures that can help mediate that. Maybe not so much of a concern for those in the northeast corridor, but in the southeast, people trying to maintain coolness in their water in the south is a challenge. But in our case, so long as it's naturally heating to an excess of 86, not a problem. We just don't want to artificially heat it. Yes, sir.
The point he was talking about things moving off the surface into the biofilter, how do you deal with leaf collection and things like that in the biofilter? Is that
Skim it,
Is
yeah.
it but stuff that like gets in among the plants and things like that, does that have to be continuously removed? I mean,
Yeah.
water features in our region oftentimes end up full of leaves.
And it won't be any different here. I mean, the essence of those environments is to collect and move water, and it's going to, I mean, gravel vacuums are popular, leaf skimmers, most of the water, like in the biofilm filters and in most areas of the regeneration zone, are going to be deep enough where you can get a leaf skimmer that in to trap it. But yeah, I mean,
But you do have to remove that. You can't
cleaning,
just let it
maintenance.
collect.
If you leave it in there, the organic matter just becomes excessive detritus that needs to be acted on and removed. So. So let's. I did want to spend. Weber Park was a great experience. This is actually, if you go to Google Maps and click on Weber Park Natural Pool, you'll see the overhead view. And this time of year, this is what you see because it's winterized. You can see the water levels drawn down inside the regeneration zone. Equipment is winterized. This is 4 meters deep, right?
Yeah.
Yeah, so beautiful clear to the bottom. This is all beach entry. No beach. Sloped entry. I've got a picture to show you how they did that, because the entire pool is lined with PVC membrane. It's said 21,000 square feet of swimming area and 16,250 regeneration. 500,000 gallons of water, and it does have a 500-person bather capacity. This is from the book, How Minneapolis Built North America's First Public NSP by Benjamin Johnson. Google it, get it on Amazon. It's the product of innovative science and engineering made possible through years of grassroots neighborhood advocacy and creating fundraising and political maneuvering. And well, that doesn't define our licensing and permitting process. I don't know what it does. But the reality is, why is it a problem? Well, because the health department says the only way to kill stuff in water is chlorine. That's what's in the code. I want to help you recognize and understand what natural pools are doing the same purpose as what chlorinating your pool is doing, just by a different method. The objective of chlorinating water is to remove contaminants, right? In a chemical pool, anything that's not water is a contaminant. In a natural pool, we secure and remove nutrients. What they view as contaminants, we view as nutrients. Because all those other things that are entering the water, they're feeding the plant and the flora and fauna. So if we create a robust biological filter of size and purpose that consumes the nutrients, we're not leaving any excess for the undesirable, unwanted, opportunistic organisms to grow and thrive in the pool. So like in nature, if you have a healthy ecosystem, it takes care of itself. If it is imposed upon, compromised, then that's when generally there's issues, even in a natural environment where nature is compromised. In our case, we're preventing the growth and prevalence of opportunistic pathogenic organisms by outcompeting them for the nutrients. They exist in far fewer numbers in the water than the beneficial organisms. By having that robust, beneficial biofilter, it's consuming the nutrients and leaving no excess. And therefore, excessive nutrients can't support the growth of opportunistic species. So in nature, it's called competition for resources. In a chemical pool, it's kill it all. And continue killing it all. And in order to continue to kill it all, make sure that the water quality, water balance, chlorine percentages, feed rate, all that is proper, because it's essential for chemical treatment. In a natural pool, we just want more consumers in the biological filter than there are nutrients entering the pool. And it creates a nutrient-deprived environment, beautiful environment. This kind of illustrates what I was mentioning earlier. These are distribution shafts in this regeneration zone. I've got upflow or downflow systems where in red, water is moving down through the system. And on this side, I've got water being pushed up through the gravel in the system. I got another picture that shows the section. But in this area here, I've got a cistern, fine filters. Most of the water is getting routed through here before it's being pumped or delivered out to the regeneration zone. All of these areas here are surface skimmers that are pulling surface water off. These are all bottom returns for water that's being pushed back into the pool. So yeah, rather large and expansive, and it's all lined with PVC membrane. You can see each of the bottom holes hand welded. It looks rather rudimentary, but it's a heat gun and a roller. It's thermal bonded, melted, welded. Excellent option for maintaining a non-porous, easy to clean surface. The other benefit compared to, say, a sack liner, vinyl liner pool that you're used to, there's no air voids. This is custom cut and designed to the interior configuration, shape, dimensions of the interior of the pool. These distribution shafts, all placed, have a purpose and function to serve in the regeneration zone. You see the deeper water area here, about 3 feet deep, where the lilies and lotuses and submerged plants will be. These guys, we've got over 7,000 plants, 30 different species of native plants in that regeneration zone. And this is how we did the beach entry. First of all, here's unlined. You see we've already got the returns here. This is a surface skimmer, already plumbed, heading back to that cistern. As we anticipated the addition of the stone, we lined underneath these, this is brushed, rough cut granite, so that on that slope there's some texture. Instead of sand, there's texture for the bathers to enter as they're going into that, and then they converted right down to the granite beach entry. It's a great option for many construction methods, perfect for this environment. And because it's such a non-aggressive, non-chemical environment, we expect the lifetime of the pool interior to be in excess of 30 years.
Alan, I placed some samples there. There's a green sample, that's what is at Weber Park.
Mm-hmm.
We have some of our textures, and then there's a regular piece of vinyl liner just to compare the thickness.
Yeah. Any questions?
What kind of pumps are you using? Just regular, like variable speed pumps or anything you find on the
We use spec, variable speed, programmable. But I mean, PacFab, Hayward, Jandy, most everybody's got a variable speed programmable pump. Beauty is we can dial that into the flow rate necessary for the system we design. So one pump can serve a multitude of functions based on
Does
this.
a low speed setting suffice to do the thing?
Mostly it will, yeah, for a slow flow filter, yeah.
Usually I use spec, so it does percentages. Usually to get 70 GP, so the typical biofilter, you can see the biofilter on the far end of that pool. That's like a 10-tube biofilter. You need a minimum of 70 gallons per minute going through that. And usually on a variable speed pump, that's like 20% on my pump. It's not very fast. But we put a flow meter right after that, and when I start it up, I just sit there and wait till it's at 70 GPM. So it's usually around 20-30% of the pump's full power. It's definitely not going full blast.
Many of you have another session to get to. Please go into the app and fill out the survey necessary for this section. Thank you for your attention and your time, and hopefully see you back here at 1 o'clock. We'll go into greater detail on some of the projects we have in biofilm filters.
Thank you.
Thank you.